Hello everyone, welcome to my channel. This is Majesty. Today I'm going to share you about mutation testing. Mutation testing is an interesting testing method I encountered when adding a feature to an SDK in my company. It is used to check the quality of unit tests. First, let's take a look at the introduction of the testing framework Striker for mutation testing. Here it mentions that bugs or mutations will be automatically injected into the code, and the unit test will be used to check if these mutations can be killed. If any of your unit tests failed, it means that mutant has been killed. Otherwise, it is considered to have survived. The more mutants we kill, the higher our score will be, indicating that our tests are more effective. Therefore, our goal can be simplified as trying to kill as many mutations as possible in the tests. Before discussing the specific mutations, we need to clarify another issue, which is why code coverage in unit testing cannot effectively achieve the goal of testing the quality of unit tests. Let's look at an example. We can see from the image that the code coverage in the test result is 100%, but the result in mutation testing is quite disappointing. This shows code coverage does not necessarily equal to the quality of the test code. Code coverage is just one indicator of test case, and the design of execution of test cases are influenced by various factors. It is even possible to have tests without assertion just to increase code coverage. Now let's take a look at an example of mutation testing. We can see there are 4 different mutations made for the given code. So overall process of mutation testing is as follows. First, identify the locations where mutations can be made. After inserting the mutate code, compile this code separately. If the project is complex, there may be hundreds or even thousands of mutations, which can take a significant amount of time to compile. Next, execute all unit tests for each different mutation. If any of the tests failed, the mutation is considered killed. If no tests fail, the mutation is considered alive. The better your unit tests are, the fewer mutations will survive, resulting in a high score. Finally, the score is calculated using a formula. So how is this score calculated? We can see there are 4 different types of mutants involved in the calculation. Killed and survived are easy to understand. Let me explain the other ones. Timeout usually refers to the situation where some tests take too long after the mutation. In most cases, it is because an influent loop is created. The most common example is when I++ is changed to I in a for loop. Another example is when the condition of a while loop is changed to true. In fact, we can consider these mutations as killed because the influent loop indicates that the mutate code is problematic. No coverage is easy to understand. It means that the code was not covered by any test from the beginning. Even if a mutation occurs here, it won't be covered. There are 2 other types of mutations that are not included in the calculation mentioned above. The first one is error, which means an exception occurs during the mutation. For example, if string operator plus is changed to minus, it will result in an error. Errors include both runtime error and compline errors. The second type is ignored, which means that it is marked as ignored for some reason. These mutations are not counted in the final score either. Now let's take a look at the different types of mutations. Here are some examples, including mutations on equality operators, logical operators, etc. We can see there are many types, so I won't list them all here. For .NET, Striker has the following mutations. Mutation testing has an obvious disadvantage, which is that it is very, very slow. The main reason for being slow is mainly due to the following aspect. If the framework needs to make a large number of education to the code, generate various mutant versions, and run test cases for each mutated version, the process is quite time-consuming. Especially when the codebase is large, the time will be longer. If there are a large number of test cases, the testing time will be also increased accordingly. Therefore, mutation testing may not be suitable for all projects. For example, the service with the most unit tests I have on hand has more than 4,000 unit tests. It takes 30 to 50 minutes to run all the unit tests once. If there are hundreds of mutations, there will be more than 10K of test cases, which cannot be complete in just a couple of hours. So if final score is relatively low, how can we improve it? Generally speaking, the previous SDKs I wrote required a score of 90 or above the mutation testing. I have summarized the following 3 points. Firstly, we need to check if our tests are sufficient because mutation test is still a method used to test tests. We need to check if we have missed any boundary cases to test. Secondly, if you think your tests are already good enough, then check if there are a problem with the original code. If your code can still run as expected, even with inject bugs or mutations, it is obviously that there may be bugs in your original code or it may be simplified. Thirdly, you can ignore or use comments to ignore certain places where mutations can occur by setting the configuration, because there are indeed some cases that are not easy to cover with test cases. That's all for today's sharing. Thank you for watching. Hit the like button if you think the video helps. Leave a comment or send an email to me if you have more questions. See you in my next video. Bye.